Algebraic reasoning, chapter 1.7, exercises 13 through 20. And I'm going to work probably the first part of this, maybe 13 and 14, maybe. Anyway, I'm not going to do, as usual, the whole thing. For questions 13 and 14, use the following information. The Texas Department of Public Safety can use the length of skid marks to help determine the speed of the vehicle before the brakes are applied. The quadratic function that best models the data is fx equals x squared over 24, where x represents the speed of the vehicle, and fx equals the length of the skid mark. The speed of the vehicle and the length of the corresponding skid marks are shown in the table below. And so we have some data. It says use the table data to determine the length of the skid mark of a vehicle that was traveling at a speed of 72 miles per hour when it applied the brakes. And so we see up here that on the left side that we are increasing on the left side by 6. So plus 6, and so on. And so for 72 miles an hour, we're going to have 2 more iterations of this table, because we have 66 plus 6, 60 plus 6 would be 66, plus another 6 would be 72. So let's go ahead and apply and see where we're headed on this. We're going to go to, as usual, first differences and second differences. And so let's just try to make the ones that are easier. So 96 minus 73.5, that's going to be 22.5, is that right? And then if we have 121.5 minus 96, that's going to be 25.5, is that right? And then 73.5 minus 54 is going to be plus 19.5. And then 150 minus 121.5 is going to be 28.5. Okay, and this last one here, looks like we're going up 3 every time. So this one over here should be, was it plus 16.5? So these will be our first differences. And our second differences are going to be plus 3. Okay, plus 3. And we can just keep on driving to get up to the 72. So here we have, we'll just continue where we left off. We'll go to 60. And that's going to be 150. And then okay, if we have a second difference of plus 3, we're going to get from, we're going to add 3 to the 28.5 and get, let's see, 31.5. So say plus, I'll say plus 31.5. So to get to get 66, 150 plus 31.5 is going to be 181.5. Next, if we add 3 again, I'll put plus 3. I'm getting off the edge of the screen here. But 31.5 plus 3 is going to be plus 34.5. And then if we add that 34.5 for 72, so 72 plus 34.5, I'm just putting it up here, take 0.5, that's, no, I want to put 181, gosh, I'm not even thinking straight, 181.5 plus 34.5, so that's going to be 0, and we're going to add that 1 up there, so we get 6, and we get 11, 2, so we're going to get 216. So that's going to be it, isn't it? So that'll be the length of the skid mark will be 216 feet. So we're just using the data here. So we'll say 216 feet. All right, that'll be our answer to number 13. Next, number 14 says use the table of data to determine how fast a vehicle was traveling if the length of the skid mark was 24 feet. Well, for that, we're going to have to work back the opposite direction. I'm going to leave it over here. In this case, we're going to have to go up 1. So I guess I'm just going to leave the table right here. And we're going to say, okay, if we went plus 3 coming the other way, we should get to 24 right back there. So what plus 3 equals 16.5? Well, that's going to be 13.5, right? So plus 13.5, and that'll be our first difference. So we say at 24, I'm going to write it over here. I'll write it in red. We get to 24, that's going to be a next increment of 6 on the left, right? So what plus 13.5 equals 37.5? That's going to be, let me say, 37.5 minus 13.5. So it's going to be 0. That's 4, 2. So that's going to be 24, isn't it? So 24. 24 plus 13.5 equals 37.5. And so when the speed is going 24 miles per hour, our skid mark is going to be 24 feet, according to that analysis. So how fast was the vehicle traveling if the length of skid mark was 24 feet? So there's your skid mark of 24 feet. There's the speed of the vehicle. So we will say for that one, 24 feet, 24 miles per hour. Okay. Next, for questions 15 to 17, use the following information. A ball is thrown upward with the initial velocity of 35 meters per second. The position of the ball over time is recorded in the table below. And I think I'm just going to maybe do 15. Just use the data to generate a quadratic function that models the data. And this is similar to what we've been doing all along in the prior video and this one so far. So we're going to have our first differences here of plus 30. And our next first difference is going to be 50 minus 30 plus 20. And then plus 10 plus 0. And then plus negative 10. And that's going to be our first difference. Our second differences are going to be plus what? Plus 30 equals 20. Well, that's going to be minus 10. Minus 10, minus 10, minus 10. So we say second difference equals negative 10. And we know that 2a is going to be equal to our second difference. So 2a is negative 10. So divided by 2, a is equal to negative 5. So I'm going to put up here in the upper right corner, a is equal to negative 5. And our c is equal to 0. So c is equal to 0. B, how do we get b? Well, b is going to be the difference between so b is going to be equal to our difference between our first difference and our second difference. Our first difference between where x equals 1 and x equals 0 is 30. So we're going to say 30 is equal to b plus a. And a equals negative 5, so 30 is equal to b minus 5. So adding 5, we'd say b equals 35. So I'll say b equals 35. So therefore, we would say our equation is going to be f of x equals negative 5 x squared minus 35 x. And we could just try this out. Okay. So trying it out, we would enter 1. So f of 0 is going to be equal to negative 5x squared minus 35x. So that's going to be 0, check. F of 1 is going to be negative 5 times 1 squared minus 35 times 1. So it's going to be negative 5 minus 35, which equals negative 40. Is that right? No, it's not right. We need 30. So we really should get plus 25 there, right? So something is amiss. Well, we have 35 meters per second here. That would be that, right? Plus 35x. Let's try that instead. I think we fixed it here, didn't we? Yeah, it caught me with a mistake. So plus 35 times 1. So we get negative 5 plus 35 equals 30. That checks. Next, f of 2 equals negative 5 times 2 squared plus 35 times 2. So negative 5 times 2 squared is going to be negative 20 plus 70 equals 50. Check. So now with a little diagnostics here, we figured out the right equation. That is it. And it really helped me to go back when I had that minus 35. I just looked and I said, wait a minute, this is an upward velocity. So I brought back my understanding of the physical world to put me back on track. So go through the rest of the data. You should be able to continue the table to do number 16, 17. And then you have 18 through 20, which is Judy constructing this rectangular pen using a quadratic function similar to what we've done in the past. So as always, good luck and thanks for viewing.